And hello friends, welcome back to this video. Alright, so in this video I'm going to describe something sort of a more, I'm going to talk about more complex transfer functions, okay? For example, multiple input, multiple output. What does that mean? It means that, let's say okay, I'm going to sort of include, I'm going to have this hypothetical system. Okay, this is a physical example. Okay, let's say you have a tank with some water. You got an inflow and some outflow, and this tank is being heated by a heater, right? So like a water heater or something like that. Okay, so how is this outlet temperature determined? How is the outlet temperature determined? Alright, this outlet temperature is determined by the temperature of the inlet, the mass flow rate of the inlet, and of course the heat rate which we give to this tank, right? The heat rate in which we give to this tank. So what we can say is that there can be a transfer function from T in to T out. For sure, if your inlet temperature is hotter, your outlet temperature is going to be hotter as well. And of course, the heat supplied. Okay, so this is a one transfer function. Okay, if there's a high heating rate, the temperature is going to increase. So this heating rate is going to have another transfer function to T out. Okay, so it's going to have another transfer function here. So one transfer function from the inlet temperature to the outlet temperature, one transfer function for the heating rate to the outlet temperature. Okay, and I mean mass flow rate sort of controls this as well. You can even have some other transfer function here. I don't know what that is, but in theory, changing the mass flow rate, right? Changing the mass flow rate will change the residence time of maybe water flowing through a tank, and that will definitely change the outlet temperature as well. Okay, and this tank, of course, I'm going to assume very simply, it's a constantly stirred tank. So it's like a CSTR kind of a setup. Constantly stirred tank reactor. So it's basically water going into a tank and it's getting stirred all around. So it's well mixed. Okay, a well mixed tank. That is the most simple assumption of a heated tank. So basically you have three transfer functions here, right? Three transfer functions. One is the inlet temperature, one is the heating rate, one is the mass flow rate in. Okay, I'm not having a compressibility thing here, so I'll leave that up to you if you want to dabble with that, but I'm assuming incompressible fluid. So there can be three separate transfer functions for each of these factors affecting the outlet temperature. And this outlet temperature is important because, well, you may be using it, this may be a house heater, for example, right? A house heater. So you want to control the temperature of the water, which can be used for the washing machine, it can be used for the sink, so on and so forth. You don't want it too hot, you don't want it too cold, right? So you want some control on this. So that to simulate this water heater, so to speak. Okay, stimulate this water heater, you will need sort of three transfer functions. Now the other method, of course, is that you have multiple input, multiple output transfer function, also called MIMO. But in this case, we only care about the outlet temperature, so maybe we can consider this a multiple input because there's temperature of the inlet, mass flow rate of the inlet, and Q rate, the heating rate of the inlet, and of course you have a single output, which is what you want, the outlet temperature. Of course, I made the very simplifying assumption that there was no heat loss. So this heat loss is controlled by some heat transfer coefficient, some ambient temperature, etc., etc. And this can even be a fourth variable. Okay, T infinity, which is the heater temperature. It's going to be the fourth variable that affects this T out. So why am I concerned with all this? All right. Okay. because we can actually collapse all these 4 inputs into something called a multiple input, multiple output transfer function. Okay, so if you change the mass flow rate, for example, if you change the water flow rate out of your sink, then of course the temperature of the outlet of the sink is going to change, or else remaining constant. So you kind of have to have a increased heating rate if you have an increase in mass flow rate through this tank heater. And if you don't do that, then you're going to have lots of changes. So you can even do a whole controller for this. Okay, but this is a very, very simplified control system setup. Okay, so that's just to give you some background why this multiple input, multiple output is important. You can collapse all these transfer functions into one VI so that it's very neat. Okay, you can collapse all of these inputs into one simple VI. Okay, so I want to start by talking how to get around to doing this. So first we'll go to Labview 2020, examples, control and simulation, continuous linear. So okay, Labview 2020, go to examples, go to control and simulation, go to control design, go to simulation and go to continuous linear. Okay, open the VI that says the simulation example transfer function. If you press play the VI, you will have all of these. Now I know it's a lot of graphs here, but let's take a look at the block diagram because that's what we want to design. So I'm going to go through this block diagram step by step, right? So first, what are your inputs? You have 2 pulsed signals. So these are like square waves, so they are like step functions. However, they kind of alter periodically. So there's a pulse signal 1 and pulse signal 2. Now what we are familiar with is this standard transfer function. They call it SISO, or single input, single output. This is the most basic sort of transfer function. We've been dealing it in the last few videos, so I'm not going to be going through it so much. Okay, we are more interested in, let's say, a multiple input, single output, as we were talking about, or in the most general case, multiple input, multiple output. Of course, a single input can have multiple outputs as well, and there's a special way we can execute that. But that one we're not going to cover so much. You can actually look at this tutorial, try and figure it out yourself how to get it done. And it says here, use a 1D array as an input for SIMO, single inputs, multiple output model. Okay, and so that's how you do it. Now, what are the differences between the way you do a normal transfer function, SISO, single input, single output, and let's say a Miso or MIMO transfer function? Okay, firstly, your data inputs are going to be different. Okay, your data inputs are going to be different. Why? Because in your Miso transfer function, you're going to need more than one output. So in this SISO transfer function, you only take in one pulse signal as your input. Okay, but this Miso transfer function takes in 2 pulse signals. This pulse signal 1, or pulse signal, and pulse signal 2. So what is the procedure for getting this signal in? Okay, so you have to build an array. So what you need to do is go to array. You go and build the array, something like this. So depending on how many inputs you want, you just drag it out. Okay, and all these inputs, you can see it is an array because the orange line here is thicker than this orange line here. This is the thin orange line indicating it's not an array, it's just a time varying signal. But when more than one time varying signal is combined with another one, so you have 2 time varying signals, you can combine these 2 into an array. So this is a thick orange line here, the thick orange line, or thick line. Okay, this is a thick line that can show that, and that will be piped into the input of this Miso transfer function. Okay, and according to this VI here, okay, what you need to do after that is to first How do you, okay, you have to use this indexing tool to turn this thick orange line into another thin orange line. So what does that mean? It is taking a so-called 1D array and it's putting that back into just a time varying signal. So where is that? You go to array and you go to this part called index array. So this is index array. This is what this one is. So you just pipe the output of the Miso transfer function in there, and then you pipe it into whatever you want, right? Okay, so that's fine. Okay, so you can use the index array thing to turn that thick orange line into a thin orange line. So that's what you will need to take note of. So that's the Miso transfer function. A MIMO transfer function, multiple input, multiple output. And remember, as I said, we can actually collapse lots of transfer functions here. And you can see in this matrix here, there are many transfer functions stored into this Miso or MIMO. Okay, so Miso or MIMO transfer functions have multiple single input, single output transfer functions to it. Okay, so this is what they do. For the MIMO transfer function, you also take in an array, which is this thick orange line as an input, but the output will also be an array, which is another thick orange line. If you want to index this array so that you can sort of just look at one particular output, you can as well use this index array tool. So if you want like to generate two graphs, you can actually just put this here. Okay, pipe this outputs into here accordingly, and then you just you can get two thin orange lines. Okay, if you want to plot those graphs individually and you see how they differ, but instead of using this tool over here, instead of using this graphing tool from your simulation palette, okay, instead of using the sim time waveform tool, okay, you can index those arrays and pass them out using local variables. It's just like what I was talking about before. So yeah, that's 12 minutes already. Ooh, okay, so let's show you some example of how to. I'll just do the Miso transfer function. You can experiment with the MIMO and CMO transfer function yourself. Okay, so let's do that. And what it will eventually look like is something like this. Okay, so you have okay, I have this transfer function. It incorporates some noise in there, a noise signal, and when I change this variable, okay, then there will be some kind of a second order or first order response, okay, depending on what I code into this Miso transfer function. So let's start this from scratch. Okay, let's start this from scratch. I'm going to cancel this. I'll close this, and let's go to control systems. I'm going to go to the simulation generation live demo YouTube demo file. Okay, in Labview, and this is where we left off. Okay, we left off here by where we had this first order and second order transfer function. Of course, the transfer function equals to 1 also exists as well. Okay, you have a first order with delay, a second order transfer function as well. So let's go through the steps to add another transfer function. So let's have a new case. We'll call it the Miso transfer function. So under this select transfer function type, enumerated thing. Okay, enumerated thing. Go to edit items. Okay, and after second order transfer function, I'll click on it. Now I'll just press enter. I'll just put this Miso transfer function example. Okay, so this is a very generic one, just to show you the syntax. Okay, and then I'm going to delete these two other ones. So we have a Miso transfer function, and let's go and okay, we have the Miso transfer function, and you'll right click, add case for every value. Make sure it's an enumerated variable. Again, right click and make sure it's you add a case for every value. Now to wire this up properly, what are we going to do? You go to Control and Simulation, go to Simulation, Continuous Linear Systems, and then you go to Transfer Function. This is the one. Okay, this will be I'll just call it the Miso transfer function. The Miso transfer function. Okay, so I'll have this. And what do I want? Okay, of course I want to input a signal into here. Okay, so I want to input a signal into here, and I want the output as well. Okay, so all right, remember the steps. Okay, so where do you edit this? How do you make this transfer function a MIMO type of transfer function? So under the polymorphic interface to the top left, when you double click this transfer function, okay, there will be CISO or MIMO. MIMO is basically, I mean, you don't have a drop down menu for MISO or CMO, but CISO means one input, one output. MIMO means multiple input, multiple output. You can actually have multiple input, one output, but all of these will be classed under MIMO. Multiple inputs or outputs. So it's easier to design it easier to input the code like that, because the other two ways are kind of redundant, the CMO and the MISO. Okay. Okay, so the way to start your Miso transfer function, your multiple input single output transfer function, is to use the MIMO polymorphic interface. Okay, so how many inputs do I want? Well, we want maybe 2 inputs for a start. You have to go to model dimensions and make sure you have 2 inputs. Okay, 2 inputs at least, and of course you can select 2 outputs as well. Then you'll really be a MIMO transfer function, but we'll just have 1 output for now for demonstration. Okay, so let's say you have a car, you want to determine, okay, the transfer function for the first input. Let's say the knob control over here. Okay, the knob, when you're changing your step signal or your outside signal, there's a certain transfer function to it. You want to change that. So let's say we are doing this. So the current input is 0 and the current output is 0 by default. So these are index numbers for your input and output. If you have more than 1 input, of course, you can go for the current input 1, current output 0. Okay, so where's this current input 0, current output 0? Which transfer function is it? It is actually over here. Okay, the first row and the first column. Okay, first row, first column of this so-called matrix over here, that will contain your first transfer function. So index of 0, first row, first column. So I want my second order transfer function here. So 1 over 2s squared plus s plus 1, that will be on the left hand side. Input 0, output 0. Okay, so this is index number 0. We start from 0 instead of 1. That's usually the case for computer codes. Okay, then let's look at this next one, which is input 1, output 0. And you can actually see which ones you are toggling by looking at this input output model. Okay, you look at the squares, the highlighted square, okay, or the one with the checkbox. Okay, so if you are dealing with the transfer function, you can actually take a look over here at the preview. So the transfer function on the left will be edited when you are checking this box on the left. All right, you're checking this box on the left, and the transfer function on the right will be checked when you will be editing it when you check this box on the right. So the transfer function on the right, I just want a simple 0.5. Okay, 0.5 gain. If you want more outputs and it sort of gets confusing, and let's say I want to edit this transfer function here, I'll just look at this box and look, I want to edit the bottom right transfer function. So I click on this one, and then maybe I'll just put the number 10. Okay, and then you'll be editing the bottom right transfer function. So it's very simple. They make it very intuitive with this input output model, and you can just check the boxes that you want to edit. So So that's how you edit this transfer function. So this is once you are okay with your transfer function setup, your two transfer functions, then just click OK. Okay, so this actually will be your transfer functions. If you want to see what it is, you can just drag it out. Okay, and that will be okay. Okay. No, I don't know. Just now it was you're able to see it, but never mind. You're able to see what transfer functions are in there. Okay, so now we'll need to pipe in an array of two signals. So the first signal, I want this transfer function, the input here, the first signal input transfer function the first signal will go through this transfer function, and the second signal will go through this transfer function 0.5. Okay, 0.5, this transfer function, I want it to represent some kind of noise, and this first transfer function here, I want it to represent, the input and output relationship. Okay, so the main input and output, that means this is the one I control, this one is the one that is due to noise. Okay, so let's just create that just for example. So I'm going to go to the build array. Okay, and then I'm going to have two signals here. Okay, so again, go to build array, and from this build array you can actually drag out how many signals you want to pipe into this array. Okay, so now we only have two signals. So remember, I want the signal I'm controlling to affect this transfer function. So I have to pipe this the signal I'm controlling into the first element. So this first element of the array, it must be the one I'm controlling, so that it will go through this first transfer function. Then I will also want a noise signal. So I go to control and simulation. Under simulation, go to signal generation. And the one we want to use today is called signal generator. I'll just put this here. Double click signal generator. And I want to go for the signal type called random. So this will be a noise signal. I'm not going to edit anything else, just the signal type. Okay, so go to signal type random, click OK. And this random signal, I want it to be affecting the second transfer function, 0.5. So I'm going to wire this to the second element. Okay, of course this index number is 0, this index number is 1. So the first one has index number 0, the second one has index number 1, which may be a bit confusing, but that's some of the convention that's being used. So the output model is here. Okay, the gain is 0.5. Okay, and the what do you call that? The input, the one I'm controlling is going to be this one. So once I set it up nicely, I can just wire this in to the input, and of course the output, if I try to wire here, it will be broken because this output will be an array. It is not a sort of a single variable. It is not a, what do you call that? Yeah, it's not a one dimension, what they call time varying double value, numerical value. So what I need to do, because this thing will actually give a thick orange line which will not match up with this thin orange line here. So to change the thick orange line to a thin orange line, we'll just use array, and then again, like what I was saying just now, use index array. So for Miso transfer functions, you don't really have to do much, just wire it into the index array and wire this out. Okay, and then we are done. So we'll press play and let's see what happens. Okay, well, it's taking a bit long. So save, and I'm going to press play. So remember, we can select it down from our drop down menu. Now the transfer function is 1. I want to go to Miso transfer function example. So now you see all the noise is starting. So this is the random signal. Okay, so I will increase the input so that the signal will be going up, and it does look like our correct behavior. So I'm going to stop, and let's say we do something. We change this transfer function. I want to change this second transfer function, so I go to the input output model. Okay, and I'm just going to add a denominator here. So it's 0.5 over s plus 1. So this is what we like to call sometimes a low pass filter. Why? It's because only low frequencies will be able to get through. Okay, so remember that the signal generator, it's kind of having this randomized signal. Okay, okay, it is this randomized signal. Okay, Labview's lagging. Yeah, it is this randomized signal. It will be jagged up and down, etc., etc. But if we put this low pass filter in, okay, low pass filter is just a first order transfer function. That's all it is. Why is it called low pass filter? Is because it filters out these high frequency disturbances. So if we press play, okay, we'll notice that the graph is a lot smoother because now the disturbances will be kind of smoothed out by this low pass filter, by this first order transfer function. Okay, but the whole point of that was just to demonstrate how you can change the Miso transfer function properly using the input-output model checkbox over here. Okay, if I change it back to 0, I can do that. Okay, it's really up to you. So remember, for Miso transfer functions, you have a build array. You need to build an array of all the signals that you want to pass into this Miso transfer function. And then you use this index array to convert the output of the Miso transfer function into one-dimensional, a variable, a number that's just changing in value, which is the output. Okay, so hope that clarifies things. So it's just a Miso transfer function example. Again, the rest of it you can take a look at the Labview examples, which are inside your Labview 2020 folder. I already showed you how to access that just now. So that's all I have. Thanks for watching. See you again.